For the second exercise, we have x of n equals u of minus n plus 1. So as we did before, we rewrite the definition for it. Okay, so let's write it here. So u of minus n plus 1 equals what? 1 when minus n plus, so this is a little bit big, minus n plus 1 is greater than or equal 0 and 0 otherwise. This means that it is 1 when n is less than or equal 1, 0 otherwise, so n should be greater than 1. Okay, so when we plug this definition here, so we get all the terms from minus infinity, right? It's less than 1 until 1. Okay, so we need to change or modify this summation to look like the infinite geometric series. So the first thing we notice that we should start from a positive integer to a positive infinity, not minus infinity. So we need to do a simple variable substitution. So say we have m equals minus n, right? So if we use this substitution here, we'll start from, we need to change the terms in the series, right? So when you say, okay, I have n, the first term, say n equals 1, gives me that m would equal minus 1, and when n goes to minus infinity, this leads to that m go to positive infinity, right? And this would change into m. So what we have here is that of a summation from m, okay, starting from minus 1 to infinity, z of m. Okay, we can simply change m back to n, so it's just a dummy summation variable. So we get to here. So this is not the infinite geometric series. We notice that we start from minus 1. Okay, the infinite geometric series starts from 0. So what we can do is we can easily separate or just let's say divide or rewrite the summation into its terms. So we say, okay, I want to write it when n equals minus 1, then 0, then 1, etc. Okay, so I need to substitute the value of n to be minus 1. So here it would be z to the power minus 1. And then I notice, okay, now I have the infinite geometric series which starts at 0. Okay, so I can write down or I can use the infinite geometric series formula here, but there's a small caveat or a small thing that we need to consider. Okay, so here for the infinite geometric series, z equals what? It's not to the power minus 1 as we used to see before, right? So here we used to say, okay, we have a counter from 0 to infinity, y to the power n. Okay, y here simply equals z. In the previous example, y equal z to the power minus 1. Okay, so we need to make note of this. Now we use a definition or the formula of the infinite geometric series. We use it here. So simply 1 over 1 minus z, and just we use some algebra again to simplify matters, right? And we arrive at this term. Okay, Now we need to find the region of convergence here. The range of convergence, okay, we need to have z, okay, less than 1. This is by definition. And of course, because it's an absolute value, it should be greater than 0. So if you want to plot the rock is the inside of the unit disk here. So this should be, okay, it's not a very clean circle. Okay, so yeah, let me try to do it again. It's not, it's a little bit better. So this is, we have a radius of 1. Okay.